Hey everybody, welcome back. So we're in the middle of the section on randomized control trials. We're thinking about how to tease out a causal impact estimate for some sort of development program or policy. Okay, last time you learned basically about how to put together a randomized control trial by creating a valid counterfactual or a valid control group to go with the treatment group. Remember, one of the key important pieces is that those two groups are supposed to be clones of each other in aggregate or on average. So basically, at the end of the last video, we talked about the importance of them having the same summary statistics or average statistics. So I want to pull up a chart from the readings that I'm sharing with you, and I'll show you. All right, here we go. I'll show you what it should look like. Okay, so what we have here is we have the treatment villages. So we have a randomized control trial done with villages. So they randomly assign some villages as treatment villages and some villages as comparison villages. You see, the numbers are about the same. You know, they don't actually have to be the same. They just need to be more than 100 each, right? Okay, and so if you look at it, they just took some summary statistics. On average, they spent 1450 or 1457 on health expenditures per year per capita. So the difference is very, very small. The head of household's age is almost identical on average. The spouse's age is almost identical on average. It is identical actually, so the difference is 0. And then the head of household's age, head of household's education is pretty close. This is the only one that's significantly different. You don't have to worry about the t-statistic right now. If you do know about t-statistics, you'll understand what that's talking about. It's basically talking about the difference of two means. But you can see, we would probably conclude, this is from a baseline survey. So we survey the individuals before they actually get the treatment. And then we look and we say, hey, these are probably pretty equal groups. Okay, so hopefully you've also watched the video on the RCT that was done on the Universal Basic Income Pilot. That's also in the syllabus, so check that video out. It gives you an example of a real-life RCT, and you can be thinking about, for the rest of this lecture, how those how that RCT works, and then you can think about, use it as an example. Okay, so we're going to talk about internal versus external validity right now. What do we mean? Well, so far we've defined the validity of the RCT by checking if, here we go, by checking if the treatment group's counterfactual was estimated without bias by an appropriate control group. So we've talked about validity, but we've talked about this kind of validity known as internal validity. So it's internally valid inside the RCT, right? So the counterfactual or the comparison group on average is equal to the treatment group. That's called internal validity, okay? There's another kind of validity that we're interested in. And this asks this question, hey, how broadly can the results be applied? The results that I get from my group of people in my RCT, can we apply them to the whole rest of the population? Now you're probably thinking, well, when might that be true? I know when that'd be true. It'd be true when the people in the RCT, both the treatment and control groups all together, look a lot like the rest of the population of the country. And that is exactly right. If the sample, all right, and when I talk about the sample, I mean all the groups of people, and then the samples later divided into treatment and control groups, all right? If the sample is itself representative of the general population, then it's likely the estimated effects will be representative of the general population. And this is called external validity, okay? So it's external because it talks about the interface between the RCT and the rest of the country. Is it valid toward the rest of the broader population? So Flowchart kind of looks like this, right? So here is my entire country, my population of eligible units. This is maybe all the people in the country, right? I randomly take some people and I form an evaluation sample. Hey, these people are going to participate in my RCT. If the evaluation sample looks a lot like the rest of the country, oftentimes we use what's called a simple random sampling, right? Then we have external validity. Okay, the people in the study are the same as everybody else, so we can carry through. Now, once I have these people, I have to divide them into treatment and control group or comparison group, right? And I want to randomly select them again, all right? So this is another round of random selection. I randomly select them either to be in the treatment group or in the control group, okay? And if I correctly do this, this is known as internal validity. Hopefully you catch that there's actually two stages of randomized selection going on here. we have everybody in the country. Some of them are randomly selected to be in the evaluation sample. And once you have the evaluation samples, some of them are randomly selected to be in the treatment and control groups. All right, so what are some concerns that could potentially bias the estimated effect? So this is just talking in being real about what happens if you try to run an RCT in a developing world country, right? So if government officials are too corrupt to make sure that only individuals who are supposed to get the treatment get it, then results will be biased and it's typically downward, right? Imagine if the treatment is some sort of cash transfer program and only people in the treatment group are supposed to get it and the control group are not. Well, lots of people are going to want to be in the treatment group. They might try to get the treatment even if they're not in the treatment group, okay? And so there's also the problem that the individuals themselves don't listen to whether they're supposed to be in the treatment or control groups. If it's a check from the government, probably the people themselves can't participate, can't change which group they're in, but maybe it's uphill and only a treatment group is supposed to get the pill and the control group's not supposed to get it, but people in the control group want it and go out and buy it anyway, all right? That's called the spillover, all right? So when people in the control group get the treatment, this is known as a spillover, okay? Here's another example. Imagine your randomized control trial gives a treatment group of kids a free computer, and in the control group, not a free computer, and we're gonna test how they do on some sort of educational test score. Well, look, if kids are going to be kids. Kids in the treatment group are going to share it with their friends. They're going to all kind of work on their computers, and suddenly we have a spillover because kids in the control group are getting access to the computer. All right. So it's less of a problem, though, when people in the treatment group are non-compliers, right here, non-compliers, which means that they don't get treatment. All right. So the opposite of a spillover. So a spillover is somebody in the control group getting something they shouldn't. Non-complier right here, that means somebody who's supposed to get something, people in the treatment group, but for some reason they don't, okay? And why is this not a problem? This is not a problem because this only affects the ITT estimate. We will still get a correct treatment on the treated estimate, as long as we know who didn't actually get treatment. We're like, hey, you were in the treatment group, but you didn't get treatment. Well, for my treatment on the treated estimate, I'm gonna exclude you. I'm only gonna look at the people who actually got treated, okay? So another way we can kind of control the spillover problem is the level of randomization, okay? So we've always been assuming that randomization occurs at the individual level. Think back to the computer example. What if, then the kids are sharing computers, right? That's because we randomized at the individual level. What happens if we just chose a whole town and everybody in that town got a free computer and everybody in the next town didn't? It's way more unlikely that the students will share computers because they live differently. It also might not always even be possible to give randomization at the individual level. Think about the treatment which gives cash to the parent of a child who keeps a child in school, right? The cash is going to be spent on all the members of the household. So if we randomly select children at the individual level to receive a cash grant to go to school, the parent gets it, and then the money's going to be spread out to all the children in that family. So really, I need to randomize at the family level there, give a cash treatment to everybody in that family. That way, it's less likely that there will be spillovers. Okay, so probably better in this case to randomize at the household level, right? So we put some households in the treatment group and some in the control group, and then on average, we can look at their averages, make sure they're same. Then we give money to households, and they go ahead and use it, and then we measure the household outcomes afterwards. All right. So we can randomize at a higher and higher level. We can go higher up to the neighborhood. So from individual to household, we can do household to neighborhood, from neighborhood to village even. That will reduce the possibility of spillovers. Think about it. The higher up I randomize, so if I randomize a whole village and then the next village doesn't get anything, there's a big separation probably in distance between the two units, and they probably are not going to spill over quite as much, right? But however, randomizing at too high of a level can also mean that there are too few units, right? So imagine that a country has 6 states. And so if you randomized at the state level, that means that there's 3 states in the control group maybe and 3 states in the treatment group. And that's not enough. Remember, we want our groups to be at least 100. So we want our groups to be 100 so that the comparison group is a valid control group. Okay, so we want to there's costs and benefits. The higher level you randomize, the lower the chance of there being a spillover. However, you kill your number of eligible population units, and you can start running into the problem where your groups are too small at that point. All right. So in general, randomizing at the lower level is better unless the spillover threat is large. Then we randomize a little bit higher to get rid of the spillover effects. All right, here's some practical considerations. Now, how can you do randomization? Well, you can pull names out of a hat. That's one way to do it. I'm talking about feasible. What can we do in a developing world country? You can roll a die or flip a coin for each person, right? So if they get a 1, 2, or 3, let's say, or maybe they get a heads, if you're flipping a coin, then they're in the treatment group, or otherwise they're in the control group. I showed you guys in class how Excel can randomly assign a number between 0 and 1 to each person. This is kind of my preferred way to randomize. If the assigned number is less than 0.5, they're in the treatment group, otherwise they're in the control group, something like that, right? You just generate the random number, rand, open parentheses, 0, 1, and it gives everybody a random number, right? So this is also important. If possible, it's important that the treatment and the control groups are surveyed. So you go and you get your data from them before and after the treatment is applied. Why? Well, after you split them, you survey everybody to get their information. That's called the baseline survey, and you're checking to make sure that they're the same at that point in time, right? And then you give them a treatment, and then you survey them afterwards. And then what you're comparing at this point is the difference in the average outcome, and then we know the treatment group, if it's bigger than the control group, it was just because of the treatment. Okay. All right. So this is kind of what I was just saying, right? Pre-survey, or the baseline, is checks for the proper randomization. Post-survey, also known as the follow-up, checks for treatment effects. Now, to be totally honest with you, the only one that's required to do is this. Okay. You only need to do a post-survey. If there's some reason with your data collection, or it's too costly, or it's just not possible, or something went wrong, you don't really need to do the pre-survey in theory. It's nice to check that your randomization was right and nobody cheated, but hey, if something went wrong, you can get away from this one. You have to do the post-survey or the follow-up, because that's how you know what the effect of the treatment had. All right, so in real life, right, we'd like to actually force everyone in the treatment group to get the treatment and everyone in the control group to abstain, right? But, you know, our notions of libertarianism or paternalism not being a good thing, we don't really want to force people to get treatments or not. This is probably, we're going to run into ethical issues too, right? And so in real life, let's be honest, some people will always get the treatment regardless of what group they're in, and some people will never get the treatment regardless of what group they're in, all right? Think about the experiment with giving kids deworming pills, right? Even there are some kids that are not going to take the deworming pills, even if they're treatment group. There are some kids in the control group that are going to get the pills. Okay, we'll call those the alwayses, the people who always get it, no matter which group they're in, and the nevers, they won't get it, right? However, and so these people are going to mess up our study. However, luckily, there are still many people who do the right thing. We'll call this enroll if offered is the name. And so basically, enroll and offered means if they're in the treatment group, then they get the treatment, right? If they're offered the chance to be in the treatment group, they go ahead and get the treatment, okay? And so here's how we identify them. And oh, by the way, we need to check out the enroll and offers. We need to know who they are, because that's how we can find the TOT effect, the treatment on the treated. All right, so how can we identify the enroll if offered individuals in each group in order to compare the two, right? So I divide my group into treatment and control, but in the treatment, there are some people who are nevers, are never going to get it. And then there are some people who enroll if offered. They do the right thing. And then in the control group, there are some people who are always that are always going to get it. We have to throw those out. We have to throw the nevers out on this side. And we just want to compare the enroll and offers to the enroll and offers. So how do I find out who the nevers and who the alwayses are? Okay, so here's how I find the nevers. Now, don't forget, the nevers are the people in the treatment group. They're the ones who are not treated. Well, that's pretty easy. In the follow-up survey, I can say, ask the individual question, were you in the treatment group? Okay, yes, check. Did you get the treatment? And if they say no, I'm like, you're a never. right? If they say yes, then I'm like, you're an enroll if offered, probably, okay? However, in the control group, it's not so easy because let's say I go over to the control group and I'm like, hey, are you in the treatment or control group? You know, I ask somebody and they're like, I'm in the control group. Okay, so you should have gotten it. Did you get it? Did you get the treatment? And they're like, no. I'm like, oh, well, I don't know if they were a never or if they were just following the rules, so they're not supposed to get one, right? So you can't actually distinguish between the nevers and the enroll if offereds in the control group. However, so how do you find the nevers that are in the control group? However, this is kind of clever. We know that on average, the people in the treatment and the control groups are the same. So if we find out that there's 10% of people in the treatment group that are nevers, guess what? We can probably say that there's 10% of people in the control group that are nevers also, okay? So the nevers are the same in each group. Kind of a little trick that we use, because on average, the groups are the same. Okay, how do I find the alwayses? Okay, well, I'll start with the easy one first. The alwayses are, you know, I go ask somebody a follow-up survey. Hey, are you in the treatment or control group? They're like, control. I'm like, okay, control. Did you get the treatment though? And they're like, yeah, I did. I'm like, ah, you're an always, because you got it even though you're not supposed to. All right, so those are the alwayses. However, in the treatment group, we don't know who the alwayses are because if they're in the treatment group, they were supposed to get it. So the alwayses got it, and so did the enroll if offered, the quote rule followers. They got it all. So how do I find how many alwayses there are in the treatment group? Same trick. All right. So what I do is I look for the always in the control groups. Right. And then I just go ahead and apply to say, hey, there's probably about 10% always is in the treatment group. Remember, the cool thing about this is I don't have to know exactly who in the treatment group is an always. I just need to know how many alwayses there are, what proportion there are, okay? So if 10% of the treatment group consists of alwayses, then I can say, hey, I bet 10% of the treatment group are always individuals also, okay? All right, so let's suppose that our individuals look like this. So I somewhere up here, I break them up, and I break them up into the treatment group and the control group, okay? And so inside each group, we have nevers, we have enroll if offereds, and we have always enrolled, right? Okay. And so how can I break this up? Well, I know that if I look in here in just the treatment group, and I know that I see 10% of them that are not enrolled, I'm like, there are 10% nevers. Okay, and see, notice this guy is outside of this circle. The circle kind of looks like it touches him, but he's outside of it. The circle are the people who actually get the treatment. All right, so there's this guy and this guy here gets the treatment. All right, so this guy is a never. And so I'm gonna assume since there's 10% nevers in the treatment group that there's 10% nevers in the control group too, right? So even if I offer to them, they would be a never. And that leaves me 90% of people in this group are offered. But I don't want the alwayses because they're going to mess up my data. They're the people who would always get it no matter what. So I need to go figure out how many are alwayses. To do that, I go jump over to the control group. All right, so this is a group not offered treatment, right? And then I ask them who, you know, everybody who got it, and I find out that 10% of people actually did get the treatment, even though they're in the control group. We're going to call those alwayses. And since there's 10% alwayses in the control group, then I'm going to say there's probably 10% in this group also. All right, so then that makes some easy math. If there's 10% that are nevers and 10% that are always, 10% that are nevers, 10% that are always, then that means that there are 80% that are enroll if offered. So these are the people right here who are going to, whoa, that's totally not where I'm trying to make that go. These are the people here that are going to get the treatment if it's offered. And these are the people who are not going to get the treatment because they're not offered it. And then I can compare, I only want to compare these 80% of the people to these 80% of the people right here. And then I want to compare the impact estimate. All right, so here's what I do. I just look at the percent of the people that are enrolled, and that's where I get, it's 80% right here, okay, because 80% do it. And let's say that I measure this group's outcome, whatever it is, Y, and then I measure this group's outcome, and I find that the delta y, or the difference in the y's between the two, is 40. Okay, so if I measure everybody in the treatment group, their y, and everybody in the control group and their y, and I see that the difference is 40. So this is important. This is the ITT estimate. This is actually the difference between the treatment group and the control group in total. All right, it's 40. But recall that I just said a second ago, really the only people that are getting it are these 80% versus this 80%. So it's watered down. This 40% is actually watered down. It should be higher. What I do is I actually divide it by the 80% because only 80% are getting it. And so when I divide it by the 80% of the people who are getting it, it makes the number go up, and it's 50. So the treatment on the treated, that means if I just compare the difference on this group to this group, the enroll and offereds versus the enroll and offereds, I get 50. But if I do it over for everybody, it's 40. Okay, and so that depends, do you want the ITT or do you want the TOT estimate? Let me show you that mathematically, right? So in addition to having 10% always and 10% nevers, imagine the average value of y, that is the outcome of interest, is 110 for the treatment group and 70 for the control group. And this is for everybody, including the always and the nevers. Okay, so I get these numbers. Where do I get them from? From the follow-up survey. Okay, and it's a valid estimate. But notice that it's watered down, like I talked about before, right? It's watered down by the never and the always groups, because those aren't really people that I gave the pill to, or I gave the treatment to, and then they changed their status, right? So this is the intention to treat estimate. This is the estimate that you would give to the government. You say, hey, if I were to roll this out in the entire population, on average, I'm going to increase by 40. Okay. But let's say we want to know the treatment on the treated. So let's ask not just what this would do to everybody in the country, which is an important piece of data. How much does it benefit the people who actually take up the program, right? And so that's the treatment on the treated, right? So I want to compare only the outcomes of the enroll if offered people in both groups, right? We can't identify these people exactly. We don't know who exactly is enroll and offered, but we do know by proportion who they are, right? So we know that 80% must be the enroll and offered type, because there were 10% each of nevers and always. 10% nevers, 10% always, 100 minus 10, 100 minus 10 minus 10 leaves you with 80%. All right, so the way to think about this is the $40 ITT estimate is being driven by only 80% of the population. But let's suppose that we wanted to scale that up, be like, pretend that it's 100% of the population. If everybody participated, or another way to ask it is, what is the effect of just the people who participated? So I scale it up, or another way to think of it is I divide by 80%. 40 divided by 0.8 is $50, right? So while the program on average raises people's outcomes by $40, for those who actually follow the treatment as directed, it raises their outcomes by 50. And those are both really important pieces of information. This is the ITT estimate, this is the TOT estimate. All right. Okay, so some more things to think about in real life. Okay, it's impossible to force everyone in each group to abide by their group's rules. We talked about sometimes people in the treatment group don't get it, vice versa, right? So as implemented, randomized trials generally take the following two forms. There's the randomized offering type, and there's the randomized promotion, information, randomized encouragement type, all right? And we'll discuss these each in turn. So you think about it, because well, I want to do an RCT trial, and I'm like, okay, here's a deworming pill. I can't actually literally throw it down everybody's throat. Okay, so let's discuss these. Okay, so randomized offering. Basically, here's what we do. It's just like it sounds like. You just offer the pills, or you offer the treatment just to the individuals in the treatment group, and you don't do anything to those in the control group. And then if all members of both groups do exactly as instructed, this is totally a randomized evaluation, and the ITT and the TOT estimates will be identical. You're like, wait, isn't this what I kind of always thought about? Yes, sort of. I think maybe a couple slides ago, we were imagining that when we offer a pill to everybody, we actually force it down their throat. That's not what really happens in real life. We just give everybody in the treatment group pills and hope they take them, and then we don't do anything to the control group, okay? Usually both groups don't do exactly as instructed, and so adjustments will be made to obtain the ITT and the TOT estimates. Okay, and those are the ones that we just discussed. Okay, the other type is the randomized promotion or randomized encouragement, randomized information. And so what you offer to the treatment group is not the actual treatment. You offer them encouragement or information on how to obtain the treatment. What on earth is this like? Okay, so this is often used when it's impossible to exclude members of the control group, all right? So imagine that there is a new well that's dug and it has clean water, okay, and it's for public usage. And you want to see the effect of the well on the village. Well, real quick, before everybody learns about the fact that there's a new well in the village, you randomly tell some people about the well, and you don't tell a control group, okay? And then you give them a couple weeks, and then you come back and you resurvey them, the treatment and the control group, and you ask them, did you use the well? And are you healthier now? What's your health? Maybe they measured the number of days you've been sick in the last week or something like that. Hopefully there are more people in the treatment group use the well than the control group. That's randomized information, okay? Another reason is, like, let's say that there's some sort of a government sponsored job program or cash aid, financial assistance, and the government does not want to restrict some individuals from the treatment, right? So the government doesn't actually want to make a control group. It's going to open it up for everybody. Well, what we can do is we can create a randomized control trial where the quote treatment is, hey, I'll help you apply for this job program, for example. And then when we compare the two groups, hopefully a lot more people in the treatment group applied for the job program or whatever this is, and then fewer people in the control group did. Okay, there's still going to be always and nevers, and those will give us our ITT estimate. And if we want to find our TOT estimate, we calculate the enroll if offereds from the previous slide. All right, so randomized promotion really works to generate a valid control group if the promoted and unpromoted groups are comparable, all right? So basically, just like randomly putting people into an actual treatment group and actual control group, you randomly assign some people to be in the treatment group where they get promoted. Where promoted, it means like they get told some information about something that you want them to do, and then you don't do anything in the control group, all right? And the other thing that's important, and you probably can figure this out, is that whatever I did to promote it, whatever information or help that I gave them, has to actually make them use it more, the treatment more. So the treatment group uses it much more than the control group. This is the same as saying that there exist enroll if promoted individuals. So whatever you're promoting, there has to be enroll if promoted, meaning if I come and I tell people, if I put people in a treatment group and a control group and the treatment group, I say, hey, I'll help you apply for this job program, but then that doesn't actually make any more people apply for the job, then the treatment and the control groups aren't going to be any different at all, and you're not going to be able to compare between the two, right? And the other thing is that the promotion cannot influence the outcome of interest directly. For example, if the promotion is a big cash reward for doing the treatment, then any changes might be from the cash reward and not from the treatment itself, right? You can't say, hey, I'm going to do randomized promotion on a job training program, and my randomized promotion is, hey, I'll give you $100 if you go through the job training program. And then you come back a couple months later and you compare the incomes between the two. Well, these people are clearly going to have $100 extra because you gave it to them. So it can't affect the outcome variable of interest. All right, so in the randomized promotion strategy, remember the ITT estimate is just the simple difference of the outcome of the interest Y in the treatment and comparison groups. Oh, sorry, in the regular RCT. In a regular RCT, the ITT is just the simple difference of the outcome of the interest Y. And then to get the treatment on the treated, in a regular RCT, we talked about this earlier, we divide the ITT estimate by the proportion of enroll if offereds. Okay, and so it's in the randomized control trial. So in the randomized offering, remember randomized control trial in real life either are randomized offering or randomized promotion. So in the randomized offering design, we first find the proportion of always and nevers individuals, subtract them from 100, and then we're left with the enroll if offered group. Okay. How can we find the number of enroll if promoted individuals in a randomized promotion method? It's the same thing, right? The difference in enrollment rates between the treatment and the control groups is the proportion of enroll if promoted people. So down here, I'm talking about randomized promotion. Up here, I'm talking about randomized offering design, right? How can I find the enroll if promoted individuals. I'm calling them enroll if promoted because this is the randomized promotion methodology instead of the randomized offering strategy. All right, and so I can just look at the difference between the two, and they're the enroll if promoted. Okay, so let's do the math again together, but with a randomized promotion strategy. Suppose that y equals 70 among the control group, and those are those who have not received a promotion, and 110 among the treatment group, those who have, right? And they were just told about given some information, promoted something. Further, suppose that enrollment rates are 30% among the control and 80% among the treatment groups, right? So after I do the follow-up survey, I asked them if they actually did this treatment, whatever it is, and 30% of the control group said yes, 80% among the treatment group said yes. Well, how many more people were influenced to do this between 30 to 80? Well, that was 50% of the people, right? All right, so then overall, if I take all of the control group, right, and it's 70, whatever the outcome is, everybody in the treatment group, it's 110. So what's the difference between the two? 40. So the promotion strategy that I ran gave me 40 extra, whatever. How do I find the treatment on the treated? Well, I know that there are only, if you look at this, how many people were changed, right? Between this and this is 50% of the people. So I take 40 divided by the 50% and I get 80, and that's the treatment on the treated estimate. So my promotion helped increase, for the people who listened to me, it helped increase them by 80, right? And that's how we get the treatment on the treated. This is how we get the 50%, because the 80 minus the 30 gives me the 50%. So note that once again, the treatment and control groups have to be surveyed before and after promotion. Enough time that after even that they can be promoted and then go get the treatment. And they must be asked in the follow-up if they got the treatment or not. We cannot just assume that because they're in the control group, they were untreated. Okay, so remember we do the pre-survey or baseline to check the proper randomization, and we do the post-survey and we ask them what group they were in and if they got the treatment that we told them about. Okay, and so that kind of wraps up randomized control trials in general. There's a lot of considerations, which we kind of talked about most of them. Randomized control trials are thought of as the gold standard, or kind of like the best way to, here, I'll put my whole face out there. Randomized control trials are thought of as the best way to really disentangle a causal impact estimate. For many reasons, they call them the, quote, gold standard of impact evaluations, and I hope that you see why. If you can properly run an impact evaluation using the randomized control trial method, you're going to get a pretty airtight impact estimate of the impact of your policy. All right, and so that's everything we're going to talk about as far as RCTs. We'll get into in future videos non-RCT methods, so other ways of doing impact evaluation if you can't actually do a randomized control trial. All right, but until then, have a fantastic day.